For now, Ken is going to get us started. We're going to kind of tag team our presentation. It's pretty informal, so feel free to interject with questions along the way, and we'll just get started.
Well, hello everyone, and thanks for coming to the presentation today. My name is Ken Loomis. I'm a web developer at Student Unions and Activities, and of course Tony's joining us, and we're also here with Ben Demery. So the title of today's presentation is Collaborative Web Development Using GitHub. And before we get started, I just wanted to say that this is a topic that our team is really excited about. SUA has been using version control for quite a while now, but when we heard that GitHub would be made available as licenses for students and staff at the U, we decided just to jump right in. So this is really a good opportunity for us today to talk to you about how we think version control can be beneficial for the university, why we think version control is important, and just how we think this can be good for collaboration between all of our different departments. So with that, I'm going to give you just a quick overview of what we're planning to cover today. I'm going to be talking about version control more conceptually. I'm going to talk about why it's really needed. I'm going to talk to you about how to install Git, if you're unfamiliar with that. And I'm also going to go through just briefly some of the terms that we think will be important for the presentation. We talked about this a little bit as a team, and we think that instead of going into specifics on Git commands and kind of the internal workings, we're going to focus more on workflow, and we think that'll be maybe a little bit better considering all the different setups that you're probably using. So once I'm done, Tony's going to talk to us about workflow specifically at SUA and how that's helped us out so far. Very entertaining portion of the presentation. After that, we're going to give you a demo. We're going to run through some quick commands running 3 different accounts. And finally, we're going to have Ben step up and tell us a little more about GitHub Enterprise and show us a couple of projects that are already underway with the university. So first of all, why do we need version control? And I think that's a fair question. I think it's good just to step back and really think about why it's needed. In order to illustrate this, let's start with just a simple example. Let's say that I am working on my web server. I open up a simple HTML or CSS source file, and I begin editing that file. All of that is fine, no problem, until, let's say, Tony opens up the same file and makes some changes and perhaps saves that file right after I've saved mine. So as a developer, my changes have been lost, and that makes me a sad developer. This could easily be resolved, however. We just make a separate copy of that file, and we start working on it independently. That way, we can save our changes, and no one has to worry about overwriting the other person's changes. And this works great until we need to bring our changes back again. At this point, we have to worry about what I've added, what Tony has added, what we've both removed. Maybe we've changed something on one line, and it just really creates a real headache for the two of us. And this could be complicated even more if there are 3 or other people working on it. In other words, we have 2 sad developers. So version control systems really step in to take care of this at the most basic level. They're used to track and store changes to the files in your project, and they really allow teams to work better on files at the same time, and it streamlines that process of merging your changes together after you've already made your updates. So we'll talk about some of the other benefits that version control systems introduce. Obviously, it's not just the fundamental piece here, but I think it's important to note that before we go into other things. So first of all, just a quick poll. How many of you are already using version control in some sort? So quite a few people. That's good. And how many people are already using Git specifically? Okay, not quite as many hands, but still a lot. Well, I was interested in just seeing kind of the popularity of Git and in comparison with some of the other version control systems that are out there. And what I did was I went to Google Trends website, and what this graph is showing me is search volume differences over time with respect to different keywords. So the keywords that I put in are Git, Mercurial, and Subversion. And for those of you, I don't know if you can see this very well online or if this is coming through all right for those of you here in the audience, but Git is in blue, Mercurial is in red, and Subversion is in orange. And a couple of things to note about this is that since about 2008, Git has really just been on the increase in terms of search volume. And since about 2011, it's the most popular search term out of the three. Mercurial and Subversion, of course, are also very good version control systems, but we just thought that it would be interesting to make the comparison. Coincidentally, in 2008, that is when GitHub launched originally. So we think that's probably due for part of the long gradual increase. So a lot of you here are already using Git, so I'm not going to spend that much time going over this. But if you are interested in getting this for the first time, the easiest way to do it is just to download one of the graphical clients. There are several of them out there, but the one I'd recommend is actually just using the GitHub client. So there are two URLs here, and you'll be able to use this after the presentation, or you can type it in right now. Alternatively, you can use a package manager, and this is going to be perhaps more useful if you're just planning to jump right into using the command line. So if you're using Mac, which many of us are, I'd recommend using Homebrew. There are also people out there who will prefer Mac ports, which is fine. And once you have Homebrew, it's just a simple command right here, brew install git, and you are up and running. On Windows, this is not exactly a package manager, but you can download the installer on the Git website. And you should have the same functionality on the command prompt. And just a few basic terms. Again, I'm going to go through these quickly because I think most people in the audience are already relatively familiar, but just to make sure we're all on the same page. Repository in Git and version control in general is just a group of files and folders in version control. It can just be a directory or a folder on your hard drive. You add some files in that, and they become part of the repository when you commit those files. You commit those files by running a command or adding them in using the GUI. Once the changes are committed to the repository, they're really only available in your local repository, that is to say the one that you're working on. If you want to share those changes with other people, whether that's, if you want to share those changes with another repository, you can either do that using, using a push. So you can push from, one repository on your machine to another repository, maybe on the same machine. You can also do that to a remote server, or in some cases, this can be just a more shared environment. And once you're ready to pull the latest and greatest changes from that remote repository, you're going to pull the changes from the repository. One more thing we think is important before we go into the workflow is to talk about branches. Branches are really just separate versions of the repository contents. So it's really useful if you are maybe working on 2 or 3 different features at the same time, where you don't want your changes from one feature to collide with features from another, and with changes from another feature. By default, Git just includes the master branch, and so if you haven't specified one at all, you can just assume that it's master. But Tony will talk about adding additional branches in a minute here. Branches are all contained within your local repository unless you choose to share them. outside, but you have to do that explicitly. When you're ready to merge changes between branches, that's also done with a simple command. And really all that merge command is doing is combining changes from more than one branch within that repository. And if you're interested in reading more about kind of the internal workings about Git, which I said we'd skip over for the most part, there's this book that I recommend reading. It's called ProGit. We have a paperback copy in the office just for reference, but you can also go to this website and read the full version online. And you can also download it in PDF, Mobi, and EPUB for your iPad or e-reader, if that's what you prefer. And with that, I'm going to hand it off to Tony, who will cover SUA process a little bit.
Okay, so I know a few of you in the room, and if you know me, you know that I never pass up a chance to make a Star Wars reference or use a Star Wars analogy. So I'm going to do that today to describe our process that we're using on the web team, the three of us right now. So this is Boba Fett's ship from Star Wars, and well, actually it's Jango Fett's ship before it was Boba. So this is Jango Fett. I found this by searching for clone on Google Images, and the first thing that came up was the little Lego clones. So I thought this is a good analogy. So I'm going to use Jango Fett to represent our repository on the GitHub enterprise server. So when I clone a repository, I'm making an exact copy. So I'm cloning it to whatever my development environment is. That could be your local machine. We have a test server where we can push and pull changes. So at that moment when I make that clone, I have an exact duplicate of what's on GitHub. So this is where, once I have that, we begin to use branches. So all of our repositories have the default master branch, and then Boba Fett on the right in the green is our develop branch. So the develop branch always has newer stuff. That's where we can kind of test things. Things can be a little broken or maybe not work quite as well as they need to. And we try to keep it isolated in our develop branch. So we have a test server and a production server. And the repository for the test server is always checked out to the develop branch. So when you need to switch to a different branch, it's called checking out. You run a checkout command. So that develop code is always on test, and production is always checked out to master. So this way, now we can all have our own copies, and we can all work in our development environments with these two branches. So those branches are actually stored remotely on GitHub Enterprise when we go to clone the repository. But now I want to work on a project, so the first thing we need to do is we want to diverge from that master branch. So we create a new branch for whatever feature I'm working on. I'm just calling it feature here. The names are arbitrary. So once again, you can see I branch, but my branch at this moment is still exactly the same as the master branch. But now I've made my changes, and I have a different version of my feature branch from master. So in order to test that, now that once I'm ready, we run a merge command to bring those changes into that develop branch. And Git is really good at, we'll demonstrate actually doing a merge without conflicts and with conflicts, but it tries to resolve any conflicts for you. If it can't, it prompts you to go in and resolve conflicts between changes. Once I've got my changes merged into that develop branch, then I can go to our test, or I'm sorry, then I want to push it to GitHub Enterprise. And the reason I wanted to do that is, one, so that it can be pulled to the test server for testing or for approval from our marketing staff. But also, now Ken and Ben can pull my changes too and merge them with their own. But what happens now, I'm working on a project that may take 2 or 3 weeks, and somebody comes in my door and says, "Oh my God, the events calendar is broken. I need, what can you do?" So I need to stop what I'm working on and begin to fix something else. So, so you can see here, this is a little bit more complex of a diagram, but so here's my feature that I'm working on. Somebody's walked into my office. I can now go back to master and branch it again to this bug fix that I know I need to do. And now this project I'm working on is isolated from my feature project, which is a much more long-term set of changes. This is something I need to do quick and get onto the server. So the benefit of this is these bug fix changes now are in isolation from whatever this longer project is I'm working on here. So this is now, I'm able to merge this and to develop before these changes are ready. And then later on, when this project is done, I can merge these changes in, and it just keeps them all nice and separate from each other, which is demonstrated here. Here, feature is in a state that's not ready. Bug fix is. So this would presumably be after I've tested it on the test server. Now I know it's ready for the master branch. I merge it into master, and then I can pull it to our production server. So that's one sort of simple case of being able to work on multiple projects, stop one, begin another, and then go back. And now we're going to actually demonstrate how you might do something like that. Ben's going to kind of start us off with that.
Alrighty, so we're going to demo a few things for you today. Basically, we're going to clone a Scratch repository that's set up just for the purposes of this. We're going to show you committing and pushing. We'll create a branch. We'll merge, and we'll also merge with a conflict. And then we'll show you kind of the result on GitHub. Alright, so we have this fancy test repository here, SUA Scratch. And what we're going to do is clone that 3 times, like we're 3 different people. We're using the same machine here today, but this would work just the same if we were all on different machines. So, alright, so here we are, and I am going to clone my repository, which is git clone, and you'll need one of these 2 URLs here, and then just copy pasta. And I'm sorry, I've already screwed up. And what I'm actually going to do in this instance is clone it to a folder of a different name, since we're doing this a few times. So now we have just Ben, which is my copy of SUA Scratch here. And then I'm going to do the same for Ken and Tony. So if I go into my copy of the repository, we have a few simple files here, CSS directory, an image directory, and our index file. Index is quite simple, and we can show you the result of what we're working with here in probably this window. Yes, this window. So this is what we're working with here. Head, shoulders, knees, and toes is what is in our body. Yeah. So we'll close the server down here quick, and I will let Ken show you some edits.
All right, I get the easy part. So Ben just showed you basically the approach to cloning 3 new repositories from GitHub. And now what I'm going to do is hop over to my copy of the repository, make some changes, look at what those changes look like in the browser window, and then I'm going to push those changes from my local repository to GitHub. So I'm going to open up a new window here, new tab rather. So index.html looks like a good place. I'll open that up. Okay. Let's actually go with the CSS file. I don't really like the color that text was showing up as, so let's change that to blue. I can run git status to see what has changed in my local repository. And Git is telling me that css/main has been modified. And that's the file that I was just in. So what I have to do now at this point is commit those changes so that they'll become part of the repository, like I mentioned earlier. So in order to commit, I first need to add. Yep.
I use this sometimes, and for me, it was helpful. The part where it says changes not stated versus it's you should pay attention. I guess my point is you should pay attention to what you're at.
Yeah, great point. So right now, when it says changes not staged for commit, those are just untracked files. It doesn't know about those at all. As soon as I do git add, that message should change. So now it says changes to be committed. Did everyone follow that?
You might want to explain what the period is rather than you did a directory rather than a file there.
Yeah, good point. Right here, instead of doing the period, which includes all of the changes, I could have specified the file directly like this. And that would just include the one file instead of including all of them as a group. So once that file is added, I'm going to commit the change. Git commit is the normal command. If you want to specify a message to go along the commit directly, you can use the -m flag.
And you should always write a great commit message.
Always. Put me on the spot here, man. All right, so I've added a commit. If I do git status, now there's nothing to commit. That is to say, there have been no changes since the last time I committed. Now, in order to push these changes from my repository, this local repository, to GitHub, I'm going to use the git push command. Git push origin master. Now, those two last words are just indicating that it needs to go remotely. And that is already set up in the config, which I guess we won't talk about today.
Oh, yeah.
So we have just one
I had
small
to
setting with Git.
blow this repository away and then briefly bring it back. So they don't have permission right now. And you're logged in, so one moment. Though this project is public, I still need to give permission to people to push to it. That's pretty easy though. Just add Ken here and Tony. And we're done.
All right. So, yep. Can you talk about that?
Sure. So origin is actually an assigned name to what's called a remote in Git. So a remote is some destination that isn't on your machine. In this case, we have, in this case, we have a URL that points to the university GitHub, and we've just assigned it that name origin. Specifically, we didn't actually assign that. It was automatically done. Just like master is the default name for the first branch, origin is the default name for the first remote. So you can change that origin to some other URL. You can add multiples. So when we specify it here, we're just being particularly explicit that we want to push to origin representing our remote, and we want to push the master branch instead of some other branch.
And that origin got set up when you did the initial clone.
Right, yep. And if you were to add another one, if you want to send to multiple remote repositories, it's git remote add destination. So
if you had an existing repository that was just local, you wanted to put it up there, that's when you do it.
correct.
So you didn't have to do that because
It was done
you cloned
before.
it. So
Because I
you
cloned
can't
it,
do
yes.
Okay.
Right. When you clone, that origin is set up by default. When you're creating a new repository, GitHub will spit out a few commands for you to run, and one of them is git remote add and the URL of your repository. So that's the origin.
Any other questions? We keep going. Okay.
I'm just curious, where did you put the different?
When when I executed git clone and then the URL, because I was cloning from remote, it automatically assigned that to origin. If you were setting up the repository from scratch, the process would be a little bit different.
So I will try running this git push origin master command again, now that it's set up in GitHub correctly. And that is successful. So it's showing that it has done everything that it needs to do. And if I run git status again, we'll still say that there are no changes to commit. So now I'm going to hand it over to Tony, and he'll take the next step here.
I guess we all have the same script, don't we?
Go up a level.
Okay. So let me review my script here. I am going to, okay, so I talked about branching in my portion, so now we're actually going to create a branch. I'm just going to take a quick look at Ben's index, and I'm not sure how hard or easy this is to see, but there's an image commented out here, and I want to go ahead and add, actually add an image to this page. You have, is there one in there by default?
There's no branch and no image. So.
Okay, so, right. As Ben pointed out, I'm on the master branch. I want to leave master sort of pristine, so I'm going to run git checkout with a B flag. So what that does when you add the -B, it's going to create this branch and check me out to the branch simultaneously. You could do this in 2 steps, but this just does it in one fell swoop. So I want to add a picture of a kitten, so I'm going to call this branch kitty. And then if I run git branch, it shows me that I'm on the kitty branch and no longer in master. So now I'm free to, excuse me, I'm free to edit this file as I want without being worried about breaking anything in the master branch. So first, I suppose I should get the actual image. So I'm going to grab an image that we found. I see nothing in here yet. So curl place kitten.com 300. Okay, and I just have to move that because that command didn't name it properly. So okay, so now I have an image to work with. And I'm going to add it. Oops. Okay. Now if we go back, oh right, thank you, Python, is it M?
Yep.
Simple HTTP. Okay. Now I have a, and you can see now GitHub is actually rearranged, or is, it's almost as if I'm pointing to a different directory. It's actually added this, well, GitHub hasn't done it yet, but this state of this website is now different from the master branch. In order for to get those changes into GitHub, I'm going to have to do like Ken did. So I'm going to do git status. And you can see that I have one modified file and one new untracked file. Untracked here. So I have to add that. And I'm going to commit. Oh yeah, sorry. So this would be a case where I'm adding them separately. Now I'm going to commit. And it says, shows me, whoops, what did I do? Two files changed, one insertion, one deletion. Gives me just kind of an overview of what it actually has tracked, the changes. So now it's clean if I run git status. Oops. Git status. Working directory clean. So now this is not ready to go up on our live website. So I'm still in my new branch. And I don't want it to go live yet. So I'm going to push this to the remote server so that Ken and Ben can then pull that new branch into their repositories and start working. So that's very similar to Ken's last command. It's just git push. Again, origin, telling it we're pushing it to the remote repository. And it's my Git branch. And there we go. Now there's a new remote branch on the server. And is that, I think that's all. I'm going to hand it back over to Ben now. Ben is going to pull these changes and demonstrate some more things with merging and conflicts.
Scott, a real quick question about you naming that. You could have named that remote branch anything you want.
Right.
So your local one could be Git and the other one cat. And it doesn't matter. You just did that for
consistency. Yeah. Yeah. So normally, in a real-world example, that might have been the develop branch.
Right.
And since I know that they are also working in the develop branch, I want to push my changes. I don't want them to go to the remote master and mess up what's on the server. I want it isolated in a remote branch for these guys to start working with.
So at any point in the day, you might push lots of feature branches all out to develop.
Right. And we're going to we'll actually talk about kind of that part of the process in Ben's next section here.
In our particular workflow, just to clarify, we would probably merge a feature branch into our local copy of develop and then push the develop branch again. But okay, so I'm in, I think this tab. Nope, this tab. Yes, okay. Just to prove really quick to you here, if I refresh on GitHub, we now have a new branch here. You can explore this, explore the source just like you would anyway on GitHub. So it is on our remote right now. So what I'm going to do is create some conflict, some angst perhaps. But first, I need to get the latest version of what we're working on. So you might remember that command is git pull. And this is actually our first example of a merge. So git pull is a shortcut command, technically. You'll probably use it a lot, but what it's actually doing is first fetching the set of changes from the remote and then merging those into what you have. It was easy peasy this time, not too much crazy stuff happening, so we see one file changed, one insertion, one deletion, and the merge method here was fast forward. So it just kind of did it for us. We didn't really have to worry about much. If I open up my index here on the other branch, sorry. I'm going to look at all of our branches here, and I'm going to check out that Git branch. Now I have an image of a cat. Awesome. So perhaps I don't like that particular cat, or maybe the image size is wrong. Doesn't really matter. I'm going to go get my own. So I'm going to download another picture of a cat here. I hope everyone likes cats, otherwise this is going to be kind of weird for some of you. So I'm going to move that file like we did earlier into there. And then I'm going to edit my version of the index file in my version of the kitten branch and include my kitten. Save and quit. All right, so for whatever reason, let's say, oh, sorry, I'm getting a little ahead of myself. If I look at my status, I have a modified and an untracked file. I'm going to use that directory shortcut again to add everything at once. I'm going to commit my changes. Cool. So I haven't pushed or anything. These changes are locally, but I'm going to check out back to master for whatever reason. Maybe I'm working on something. And let's say, perhaps by accident, because you probably shouldn't be doing this, that I edit this line that still has not been merged in from our kitten branch, and I add a different kitten. Okay. And just for the sake of consistency, I'll go get another kitten. More kittens can't hurt, right? Okay, so maybe they can. You guys didn't seem in agreement with that. Cool. So now I'm on the master branch, but I've created an issue here. I have uncommitted changes here, but I'm going to go ahead, add, and commit that. And now I have a conflict between two of my branches. I have one line that says one thing in one branch and the same line that says another thing in a different branch. And what happens when I try and squish those branches together, say I'm ready to push this to production, I'm going to get a merge conflict, or hopefully. So I'm in the master branch right now. I'm going to run git merge on the target branch, and it will always merge the current branch you're in as the destination. Oh no, I have a conflict. So it's going to tell me where the merge conflict is. It's going to be very explicit about that in git status, unmerged paths. So what you have to do is you either have to resolve the merge conflict, or you can use one version of the file over another. So say you want to use your version, you want to use the existing version from the branch that you're merging from, or you want to fix it all together. For those of you who maybe have used Git before, have seen this sort of thing, my index file now looks like this. These funny markers here are markers, and they indicate where the conflict is. If you remove these markers in a certain way and then add that file again, that will consider Git will consider that resolved. What I'm actually going to do is use their version of the file, but perhaps I want to look at the difference one more time. So I'm going to git checkout and use this handy hours command and specify my file. And now if I look at index.html, I'll see that it's my another kitten. If I git checkout, oops, there's index.html, I will see it's the other version. So we've actually checked out a single file in this instance, and I'm going to go ahead and add their version of it. What this is doing kind of internally, if you're interested, is it's taking one version of the file and it's actually putting it back in the Git index. So now if I look at my status, I have changes to be committed, no more conflicts. Git considers this resolved. So I'm going to commit my changes. This is not a very good commit message, but I'm going to go ahead and push this to remote. And then if we go back over here to GitHub, we'll see that our master branch has that latest commit message. And if we look in the index here, it's using that version of the cat from my modified version of Tony's branch. Even though I made a change to it, I created a conflict, I resolved the conflict, and so this is the version I have. In brief closing for my portion. I know that was probably pretty complicated. It's kind of a lot to throw out at once. It's tough to learn, and sometimes you have to stumble around a little bit. Hopefully you've seen a few shortcuts that you can use here. When I started out, I didn't know the ours and theirs. I was resolving conflicts by an exceedingly manual method of deleting markers. If you think you're spending too much time on it, do some investigation, especially look at that Pro Git book. There's probably a method out there for you. So I'm going to let Ken wrap up with his repository and show you where we're at.
All right, this is going to be pretty brief, actually, but so meanwhile, Ben has been doing all this really hard work, and I've just been off, I don't know, exactly. And now I need to go in and just, you know, receive the changes that he has, that he's made and already pushed to GitHub. So all I'm going to do is pull those changes. Just make sure I'm in the right place here. And as you can see, I've got the kitten images. I've got this index that's been updated. Let's just make sure that's the correct one that we were expecting. So my kitten is the right one. And now I can immediately just go in and run this server again. To make sure that it is as I'm expecting. There we go. So this has been, this is the new kitten image. We've got the blue text instead of the red, and this, while it's very simple, represents the changes of all three of us. So definitely a lot of potential for saving us time on other projects as well at the university, which I think is a good segue for Ben's portion on GitHub Enterprise.
Here's some examples of what GitHub can do for you. GitHub has a very strong social element. It really, I feel it does its best to encourage collaboration. Besides being able to do all the magical distributed version control things that we've tried to show you here, you can follow other developers by username, get kind of a digest of what they're doing when you visit GitHub. You can watch projects specific repositories, so you get changes from there. You can star those projects as well. The README is, I think, a pretty valuable feature of GitHub. When you visit a repository, you have the option of including a README file that displays basic information about what's going on with this repository right when it's opened. If there's basic setup to do, you can include it there, include kind of a digest of what's happening in your repository. You can also create a wiki dedicated to a repository. Say you have a much bigger project. You need to put a lot of information about what's going on with it. You can spawn up a wiki associated with that repository and put all that information in there. And then additionally, there are gists, which are a kind of GitHub spin-off feature. If you've ever used Pastebin or any other of the numerous services where you can paste in code, give somebody a quick link, this is like that, but it's associated with your account. It's kind of a unified service, great syntax highlighting. So there are just, beyond that, GitHub also offers forking, which is a really cool feature. Say Ken's worked on some cool project. I think his project is pretty cool, but not super cool. So I can fork his code, get my entire own copy of it under my username, make all the edits I want to it, and it will continue to stay associated to Ken's original repository. It will say forked from pretty much on every page. That leads into the next thing. Say I have actually created a feature and I want to give it back to Ken. Open source is cool, everybody's sharing. I want to share my feature back with the original project. Maybe it'll get further distribution that way. Maybe it's I've spent some time on it and it's no longer just useful to me, it could be useful to many people. I can create a pull request with certain elements of my code to be sent back to Ken's repository. If he accepts that pull request, that code is now in his repository. It will still be attributed to me as far as the message that goes with the commit, but it'll be in his. maybe he's sending out this build to a lot of people. It's pretty cool. And it has a great interface, really usable and generally pretty easy to do what you want to do. GitHub at the U has some interesting features as well. Because it's in the university community, we all have our X500s. It's a little more tight-knit than GitHub.com, which, as some of you probably know, is very vast. You can still create organizations, private repositories, all that jazz. But what we think is one of the really cool things that we can leverage with GitHub Enterprise at the U is pull requests. Like I said, take your commits, pack them up, send them to the master project. You can get those changes integrated. As proof that that's pretty cool, I'm actually going to give you a little snippet of the header and footer project that Tony mentioned earlier. So UREL has their organization, and here is the header footer project on github.umn.edu. There have been a number of pull requests on this project. I happen to have an open one right now. So this is a CSS-only search dropdown for smaller screen resolutions. I've associated some information about what I've done here, where I tested it, that sort of thing. You can see this pull request is open. It hasn't been integrated or denied or anything like that. And then you can see I've packaged 2 commits with this. They look roughly like this, changed a bunch of stuff, all that jazz. But we can, what's in kind of summary, what's really cool about this is the cross collaboration between departments on projects that are with organizations that have a wide scope like UREL, that sort of thing. We think the potential for collaboration here is very, very cool. Let me get back to my presentation so I don't get too sidetracked, because I think it's really cool. So that was an example pull request. I'm going to let Tony actually show you another one here quick.
Yeah, so this one is not nearly as active of a project, but you may or may not know that the Web Standards Group launched a new website on WordPress this year, and so I put the WordPress theme up on GitHub as a public repository too. So this is now available for anybody to review, to fork, to use as they like. And actually, I think as an extension of the header footer project that Ben was looking at, we're actually going to look at continuing that group to develop WordPress and Drupal themes that have the header and footer code integrated into them for the community to use. So this is just another quick example of another project that's available on GitHub right now. Do you have more to talk about?
I'm not sure I do, actually.
I think that might be.
It's that one.
It's our last slide. Okay. So Kamal is actually here to talk about what it takes to actually get signed up with GitHub, if anybody here is not, and if they're interested in doing so. Yeah.
So after this awesome presentation, I'm here to sell you on this and tell you how much it costs. I'm Kamal Badur from the College of Liberal Arts, and I'm here because my college, in association with ASR and Universal Libraries, has started this, and we somehow end up running it. So GitHub UMN.edu is a local virtual machine. It's not on github.com. They have nothing to do with it other than selling us licenses. We are running this. All the repos are hosted locally. We back it up locally. And everything that you want to keep here actually stays here. And that's the key advantage over github.com. GitHub.com is where you put stuff that you want to share with the world. Open source, everything is awesome. You want to, tell everybody what you're doing. But you can't help but telling them. Everything is essentially public. And that doesn't quite work for a lot of things that we do around here. I'll give you some examples. Our settings in CLA are keeping machine configuration information in GitHub Enterprise. We don't want to share that with the world because we don't want to let people know how exactly we are running stuff. People in Duluth are doing things like firewall configurations, how their network is secured and configured. And that kind of stuff really doesn't belong on the commercial public version of this. So libraries, ASR and us, we started working on this, feels like several decades ago, to get it going. But as it turns out, that GitHub had a really terrible time writing a contract with us. They were not used to an institution like the university, with all sorts of hang-ups about, who's responsible for what, who can sue whoever. So it was a long while to write a contract, but finally we did it. And this has been now in production since March, I want to say. Yeah. So again, we're running it here. It's all operated locally. You're not giving anything. You're not giving anything to the outside world. This may or may not be a good thing, depending on who you are.
So when you make something public on a university GitHub, that means university public.
Yes, universe public. Nobody else gets to see it.
Have an X500 and be signed up in order to
yes.
But then everyone who is on the university GitHub will see it.
Yes, and
you can still make private ones. Yes,
and that's really why we got. I mean, it's kind of having your cake and eating it too. If you are doing your firewall configuration that you don't want anybody to see, you can make those private and nobody will get to see them. Even we can't as the sysadmins. We were trying to do some administrative interface to this. There is no way we can tell who's committing to a private repo, for example. It's all very deeply hidden. But at the same time, if you want to share something with the entire public, like this, your relations project, I mean, there's no point in hiding the header and footer stuff, for example, from anybody. That then they can say this is a public repo. If you want to do something special, you can fork it and make that private if you want to. But again, this gives us choices that we don't have with GitHub.com. That's what we are getting to. But these choices are not free, and this is something that that keeps coming up over and over when I talk to people about this. GitHub.com is either free or very cheap. I don't quite know what the difference between the non-free version is, but you can pay them
something like 5 private repositories is $7 a month.
Yes, so you can get that 5 private repos for $7 a month, or you can get it for free and you don't get any private repos. You just use the main product. Our version is not that cheap. Our cost is $187.50 every year, and that's per named user. So these guys, if they have 3 developers, each of them will have to pay for one account. You can't have a student developer slot where you can, have Jim, Bob, and Tom switching places and using the same account over and over again. That wouldn't really work. So you need to buy a license for each user, and it's not super cheap. But I'm using it for our developers, for our admins, and for our research staff, and we're paying for something like 15 licenses. And it's totally worth it for us because we really would like to be able to keep things private and still use this tool. I mean, before we used SVN, we had our own SVN server. That was fine too. But like these guys demonstrated, this does a lot more than SVN did for anybody, or CVS or any other, still perfectly fine version management, version control tools. So this is working great for us. We really like the idea of doing this for the community. I checked this morning. We have about 150 users. We can't tell whether they are active or not because, like I said, I can't check what they are committing or not. But there are this many people who logged in and use this. And the way to use it, just to get to my core point here, is anybody with X500 can go and log in. It's integrated to University LDAP. Right now, you can go and log in and do whatever you want. We can't close that to people. That's the way the appliance is configured. What we would like to do is, and here's one more point. If you are just going to look at stuff, it's free. For somebody who's just going to check out other people's code or look at a project and then move on, we don't want to charge any money. If you are working on it, however, we do want you to pay. So these guys, for example, are obviously using this very heavily. It's in their workflow. They are using it as part of their business. We expect them to pay. But if you are just reading, we don't care. And the appliance is configured that way. You can just go and read any public repos, browse through cool stuff your friends are doing. You can share links with each other and do everything you want. That's one thing. The other thing is GitHub is really interested in increasing student adoption of this tool. And as part of to facilitate that, as part of this license, they have given us the permission to to provide this to students completely free of charge. So any student in the institution can use this without paying. The exception is student workers. If you have a student who is working on your team, who's doing actual university work, we'd like them to pay. And we are looking for a way to differentiate that. But right now, for example, in the computer science department, they have a couple of classes where instructors are using this instead of SVN like they used to. And now students are using GitHub to share their code with the professor. Professor can create a repo, they can create branches from that, and code sharing is much simplified as opposed to emails or whatever's, or even SVN. So it's not a huge amount of adoption yet, but this, like I said, this covers all students in the institution, regardless of where they are. And there is a nominal fee for this, and for this year, computer science and CLA throw it in. It's really minimal. Since we have 69,000 students, we can potentially use it. So we're very happy to provide that. And if you have any student collaborators who would like to work with, they can use free of charge. So go ahead. The instructors are paid employees, so no. So, but if the instructor doesn't commit anything, then, like I said, we don't really want them to pay. So if the instructor is not working on a project together with the students, and if they are just reading assignments or collecting assignments from them, that's fine. But otherwise, I mean, we really push for this. We want researchers and faculty to get it for free as well. But GitHub wouldn't budge on that yet. We'll keep pushing when licenses are for negotiation. But right now, they distinguish only between students and paid staff, regardless of what they are doing. So if you want, $187.50 a year. Yeah. And so for those of you who are interested in using this, like I said, you can start today. We don't control it. We don't have to grant you permission. We don't have to grant you anything. You can just go in and log in with your account and use it right now. Go to that, go to this, and you're there. But if you are going to use it seriously, I would appreciate if you can send us an email with the EFS string that you want to charge, and next time we'll buy a batch of licenses, we'll include yours and let you know. And the way licensing works is kind of complicated. You can buy individual licenses. You have to buy 20 packs. That's another GitHub business method that they won't change for us. So what we do is we don't want to go and we don't want to charge you money before we actually have to go and buy the license. So we collect people until they reach 20, and then go to GitHub and say, okay, now we are in month 6 of our contract. Give us a 6-month pack of 20 licenses, and we'll pay you for that. And when the renewal is due, I think in March, then we'll tell you for next year you're going to pay this much. So hopefully we'll only charge you for the amount of time you are spending on a given contract year. So your first year is going to be less than $187.50, but I don't know how much. So anyway, we won't charge you immediately. It will depend on when we get to 20 people in a single pack, and then you'll get charged. But again, start using it right away if you want to. No limit to that.
I actually have a backup plug if it's okay. I am officer web development student group, and hopefully this isn't licensing. I'm a student developer, but a lot of my fellow group members are not active developers. They're just students, so they're able to log in for free. And we actually have a student group organization set up on the GitHub UMM. We keep our brand assets there and our rather small website. So that's one thing that we're using it for that we thought is pretty cool so far. We can get followers there. People can see our code. People can commit to it if they want new stuff on our website. They let us know with a pull request, and then we can push that live. So that's the cool thing we're doing.
So again, please keep in mind that we can look at anything we want for free. You don't have to worry about paying us if you are just going to look at other people's code. We want to make that clear so that there is no. I mean, you shouldn't worry about having to pay us just because you'll get stuff. I think that's a very valuable thing for people to have this centralized repository of knowledge, and you should only pay for it if you are using it. And we can't tell whether you are using it or not, by the way, just by looking at your name. We have to do some work, and I'll be doing that work, once a month or so, and then I'll bug people who didn't give me any FS string, but who are working on it to say, maybe you should, let us know that you are, when you want to pay. But it's not going to be a, very difficult process, I'm hoping. Yes?
I just want to be clear, I'm sure I understand this. If a department to use that, and we ask you how much will it cost, you're going to say, how many people do you need it for? It's 100.
$87.50.
I'm sorry.
$187.50.
Per person.
Yes.
So it doesn't matter if it's one department.
No, no. It's all named seats. GitHub charges by named seats. There is no all you can eat. There is no department entity. I mean, you can create a department in it, like these guys did, for example. But for licensing purposes, you are individuals, and your department has to tell us, you have X people. Yes.
So if I'm using it right now, and I've got several repositories, but I haven't paid anything, so eventually I'll have to pay for my seat.
Yes.
If I'm using it.
So you'll get an email the next week or so.
Get in there, use it, get it into your workflow, fall in love with it, and then do that all for free now, and then eventually you're going to have to pay. And of course you're going to pay because it's in your workflow.
Well, I wasn't looking at it that way, but sure, why not?
So that's good.
Look, I haven't been able to pay too much attention to this until until now. I was out for a part of summer, and I have other stuff to worry about than this. But the idea is, once you start using this, within a couple of weeks or so, you'll get an email invite to. Well, you'll be subscribed to a mailing list, so that we can communicate to you outages or upgrades or stuff like that. And that mailing list welcome message actually describes what I'm talking about here. So hopefully within a week or so after after starting to use it, you'll get the email saying, "Hey, before you fall in love with it and realize you don't have enough money, here's what we are going to do." And I don't know how we are going to go about that quite yet. But if you never get back to me about how we want to pay, we can actually disable your account, delete your account, and remove your stuff. I mean, we can't sustain this if people don't pay, because GitHub can and will come and audit us. And if they say you paid 60 for 60 users, you have 200, somebody's gonna pay me 140 times 187. And I don't want the ASR, CLA, or OIT or anybody to be on the hook for that. So in that case, we'll say, all right, we'll disable all the people who haven't paid and tell them to move on. So hopefully we won't put you into the. This is not some sort of bait and switch. I'm hoping it just turned out to be like this for over the summer because we didn't get the email invites out to people and the explanation. It's been out there, but if you hopefully listen to this in settings like this, I'm hoping they link to our documents and FAQs and stuff like that. Again, all of which point these out hopefully in a clear way. Yes.
I just noticed the other day that the old app on Google Apps, I guess everything's available now. So have you guys looked at how that compares with GitHub Enterprise?
I'm going to leave that to the developers who might have looked at it.
In my humble opinion, I'm trying to be very humble, I think GitHub is far superior to Google Code. I have used both. I have browsed both casually, and like I said, I've used and browsed both. And I think in almost every facet, GitHub will provide you more functionality. I'm trying to be as non-biased as possible here. I really do think it's better.
Well, and I've noticed that scores of open source projects that used to be on Google Code, now there's just a little message that says, we've moved to GitHub. So,
I've heard that anecdote too.
yeah, I mean,
It's a trade-off between free
Yeah.
versus $187 a year. So I've got to pay. And I've got faculty that are using the material, are using self-version, not necessarily going to change to using different set of software.
Do you think Google Code actually has a domain repository of some sort? Is it? I mean, if you put stuff up there, would it keep it non-public?
I hope so, but I haven't looked.
Okay. I mean, for us again, that's the key differentiator here. I mean, I'm perfectly fine paying $3,000 a year for this for our developers, so that we don't have to put our database connector code out there that will expose people's soft variable names and whatnot. And for faculty, of course, these are the very. I mean, I talked to faculty about this. They have very different considerations. They have IP issues. They have their own proprietary stuff. But at the same time, they also want to share. And unfortunately, like I said, we can't offer this for free yet. I'm hoping GitHub is going to become a little more flexible about that, so that we can say, these people really are not making money off of this. It's not, part of their commercial work, which it still is for most of us here. And we get paid to develop stuff. But faculty are in a different boat. I'm hoping they will eventually come to see it our way and do it, but for now, no. Can I ask you to send the emails you got from us in that mailing list to forward that to this group so that the documentation is shared?
Sure. Yeah.
So that way, I mean, you can have a reference for the stuff that I talked about here. I'm hoping that we're not doing anything that, anything like a bait and switch. It was not our intention, but if it feels like that, I apologize.
I wasn't saying that.
But I understand your point. I really hate that kind of tactic, and it wasn't a matter of that.
I've been using it since June. I have several repositories, but I have no idea.
Yeah, then it's a communication failure on our part. We should have done it better.
The room too, that they can go out there, and it's not just read. You can go out there tonight and be like, oh look, I can create a repository. But
yes, and
which I think is fine. I think it's a
Yeah.
great value and have a total pay for it.
to be honest, I wish we didn't have to do it this way. But the way GitHub configures the appliance that we have to run, it's open into the entire LDAP domain. You cannot say I want to have a group that's paid users, view-only users or students. You can't manage it at all. You have to let everybody in or nobody in, and then you have to do stuff like this to manage it. They promised us eventually that they will have, a simple group lookup in their LDAP functionality that we can use to say these people are paid users, these are test users or whatever. But right now we don't have it, so we have to do it in this, semi-crazy way. And I'm hoping it's not going to bother anybody, but and the utility is there, like you said. I think it's totally worth it. I'm hoping you guys will agree. Anyway, if you have any questions, you can send it to this list and they can forward to me. My email is kemal@umedu if you want to send me any questions. And if you are using it and using it for real, expect an email from me soon asking for money.
All right, thanks everybody.
I over-ordered on the sandwiches, so.